Welcome back to topic 47 for Algebra 2, Inverse Functions and Relations. In part 3, we're going to explore how to find inverse relations algebraically and then use that to verify if two functions are actually inverses. So what we've learned in part 1, in order to identify inverses, what we're first going to do is we're going to switch the x and y variables in the equation. Then what we're going to do is solve for the y variable. So in this example here, we have y equals 4x plus 2. So I'm going to first swap out my x and y, and this will change to x equals 4y plus 2. Now we want to solve for this y variable. So I'm going to try and isolate it. First, I'm going to subtract 2 from both sides. Keep that equation balanced. We get x minus 2 equals 4y. Now, since the 4 and the y are tied together with multiplication, the inverse is division, so that's how we can undo it. We're going to divide both sides by 4, and our inverse is y equals x minus 2 divided by 4, or we can also rewrite that as y equals 1/4 x minus 2 divided by 4 simplifies to 1/2. So same thing there. For this next example, we have f of x equals negative 2x plus 5. Again, whenever we see an f of x, we can really rewrite that as y equals negative 2x plus 5. So just know that those two values, f of x and y, are really interchangeable. Here then we're going to swap out x and y, so we'll get x equals negative 2y plus 5. And now we're going to solve for our y variable. So we can subtract 5 from both sides. And we have x minus 5 equals negative 2 times y. Divide both sides by negative 2. Remember, keep that sign with that coefficient. And this will simplify to y equals x minus 5 divided by negative 2, or it would commonly be rewritten as y equals negative 1/2 plus 5/2. And that's because we have a negative divided by a negative, so that's where we get this positive. Now, because our original example had f of x, we can also rewrite this with the inverse notation. So f inverse of x is, oops, I forgot the x there, negative 1/2 x plus 5/2. Don't leave out your variables, because otherwise then I would not be done. I would need to combine my like terms, but these are not like terms. So keep your variables. Moving on to our next example, f of x equals x squared plus 2 when x is greater than or equal to 0. So another way that we can rewrite this, again, since f of x and y are interchangeable, this is the same thing as y equals x squared plus 2. So we're going to swap out our variables, x and y. So we have x equals y squared plus 2. And then solve for y. So subtract 2 on both sides. We get y squared equals x minus 2. Then we can take the square root of both sides. So we'll get y equals the square root of x minus 2. Now remember what we dealt with in part 2 of this, how we have this x is greater than or equal to 0. This is because we're restricting the domain. So in order for this to actually be an inverse function, we need to restrict the domain. So this is why this is just going to be the positive part of it. Our next example, we have y equals 1/2 x cubed minus 2. So we're going to swap out x and y. We have x equals 1/2 y cubed minus 2, and then we'll solve for y. Here what we're going to do first is I'm going to add 2 to both sides. And we have x plus 2 equals 1/2 y cubed. Now, since this is 1/2 times y cubed, we're dealing with division right here with this 1 divided by 2. So I'm going to multiply both sides by 2. And that way these coefficients will cancel out. I can distribute on the left-hand side. So this will actually give me 2x plus 4 equals y cubed. And now in order to undo this y cubed, we're going to take the cube root. So what we're left with is y equals the cube root of 2x plus 4 as our inverse. Now you might be given 2 functions and asked to verify if they're actually inverses. So what this deals with is composite functions. So in order to be inverse functions, we have f of g of x equals x and g of f of x equals x. So both of them have to be true. In other words, we can rewrite this as f of g of x gives me x and g of f of x equals x. I like seeing it the second way because it provides more of a visual representation for which are my inner functions and which are my outer functions. So with my first example, I'm going to identify which one's going to be my inner function, which one's going to be my outer function, which one is going to be f, and which one's going to be g. So let's have y equals 4x plus 2. This will be my f. And then y inverse equals 1/4 x minus 1/2. This will be g. So if we first want to verify that f of g of x equals x, my inner function is going to be g of x. So wherever I see an x in my outer function, that's what I'm going to put in. I like to write my outer function first, and wherever I see an x, omit it and leave a space. So since my outer function is 4x plus 2, I'm going to have 4 blank plus 2, and in that space, I'm going to write my inner function, 1/4 x minus 1/2. Now I can simplify and distribute and see if I get x as my answer. So if I distribute, I end up getting 4 times 1/4 x equals x. 4 times negative 1/2 is negative 2, and then plus 2. So after I combine my like terms, this equals x, so it is true. However, we're not done yet. We have to make sure that g of f of x also equals x. So if we have g of f of x, this time g is my outer function. So wherever I see an x, I'm going to leave a big space. And in that space, I'm going to fill it with my inner function, 4x plus 2. Now here I can also distribute. 1/4 times 4x gives me x. 1/4 times positive 2 gives me positive 1/2. And then I'm subtracting 1/2. Combine my like terms and I end up equaling x. So this first example here, they are inverses. Let's look at our second example for more practice. F of x equals x squared plus 5 and g of x equals the square root of x minus 5. So here they're already denoted for f and g. So so we can just fill in. Let's start off with f of g of x. So f of x is my outer function. So here I'm going to leave a space where I see an x, square that, and plus 5. G of x is my inner function. So this is the square root of x minus 5. So we'll need to square this. Just for a visual aid, I'm going to rewrite this up here. So this is the same thing as the square root of x minus 5 times the square root of x minus 5. Now we can FOIL, or multiply. And once we combine our like terms, we'll get x minus 10 times the square root of x plus 25, and then plus that 5 that was on the outside. Now we can combine our like terms. So we'll get x minus 10 times the square root of x plus 30. However, this does not equal x. So far they are not inverse functions. Let's try with g of f of x just to confirm. So here, my outer function is the square root of x minus 5. Wherever I see an x, I'm going to leave a big space, then minus 5, and where I see that x, I'm going to put my inner function. So x squared plus 5. Now because this plus 5 and this minus 5, one is in the radicand and one is on the outside, I can't combine those like terms. So this is actually as simplified as I can go. This also does not equal x, so neither of the functions are inverses. And that was part 3 for topic 47 for Algebra 2 on inverse functions and relations. Thanks for watching.